Hidden FIA images of McLaren's 2026 car just leaked, and they reveal a design so radical, it could get the team in serious trouble. The files are stamped with Oscar Piastri's name, showing systems that may already violate next season's rules. If this leak is confirmed, McLaren could face grid penalties or even a forced redesign months before the first race. We broke down the full leak, the secrets inside, and what it means for 2026, so hit that subscribe button right now and don't miss a single turn in the biggest F1 story of the year. In the early hours of Tuesday morning, encrypted FIA technical documents began circulating through a closed motorsport server, and within hours, they hit the open web. What they revealed was explosive, detailed internal images of McLaren's 2026 chassis, complete with dimension markers, aero overlays, and system labeling. These weren't rumors. These were direct files from an FIA development review, including Oscar Piastri's name and code assignments linking the design to driver-specific simulations already underway. The timing of the leak couldn't be worse for McLaren. Just as they approach the midpoint of their 2026 concept validation phase, they now face a full-scale exposure of their engineering direction. Technical secrets developed in silence over the past year, strategies involving battery placement, floor geometry, and aero tricks are now out in the open. These weren't final parts, but sensitive concepts still being debated inside engineering rooms in Woking. And now? The entire grid has access to them. The leak is especially dangerous because of its origin. The presence of FIA compliance tags and homologation stamps confirms that this wasn't an accidental internal McLaren upload. These images were part of an official regulatory dialogue, meaning they were likely stored on secure FIA infrastructure. If that's true, the breach raises serious questions about digital security inside Formula One's governing body, and whether other teams could be vulnerable to similar exposures. Oscar Piastri, named repeatedly throughout the blueprint, is at the center of the controversy. His chassis reference is linked to specific ride height data and electronic override systems. That means this isn't a generic test mule, it's a car built with his driving profile in mind. While McLaren hasn't commented publicly, internal sources suggest the car was already being used in simulation feedback loops with Piastri in the seat. In other words, this wasn't theoretical. It was active development, and that's what makes the leak so serious. For McLaren, the implications go beyond embarrassment. With this information now public, competitors have the chance to reverse engineer elements of the design, simulate airflow patterns, and preempt McLaren's own innovations before they're even track tested. And under the highly restrictive 2026 rules, where every design advantage must be earned through efficiency, any early exposure can destroy a team's competitive lead before a single lap is run. The FIA now finds itself in a precarious position. Do they admit the leak and open an investigation, potentially destabilizing other teams and revealing systemic vulnerabilities? Or do they stay silent and risk being seen as unable to protect the very compliance process they enforce? The answer will define how much power the FIA truly holds in the new regulatory era, and how seriously teams can take their assurances of confidentiality. And through it all, the rest of the grid watches silently, carefully. Red Bull's aero analysts are already simulating McLaren's floor. Mercedes will be comparing thermal maps. Ferrari's legal team will be looking for anything that even hints at a regulatory overstep. Because in Formula One, secrets are currency. And McLaren just had their vault cracked wide open. The first and most striking revelation from the leaked FIA images is the aggressive reinterpretation of the side pod design. Unlike the wider, scooped pods used throughout the 2024 and 2025 seasons, McLaren's 2026 prototype shows an ultra-tight inlet structure, sharply contoured to hug the car's central core. This suggests a deliberate airflow strategy, likely aiming to funnel cleaner air to the floor and diffuser while minimizing cross-flow turbulence. It's a bold decision, but one that drastically reduces surface area for thermal dissipation. That's risky, especially with the tighter cooling regulations coming in under the new 2026 engine architecture. Equally radical is the underfloor configuration, which appears to push the limit of ground effect legality. The design shows a dual-stage Venturi tunnel with a rapid inlet taper and a much longer exit ramp than expected under the new rules. These contours are designed to increase suction under the car, essentially trying to claw back lost downforce from the 2026 drag reduction mandates. However, the FIA's updated wording on passive aerodynamic structures may put this layout under scrutiny. If the floor flexes or deforms under load, it could be seen as a form of illegal aero activation, a breach that has triggered sanctions in previous seasons. The suspension architecture provides another key insight. The car appears to use a reverse layout with pull rod activation on both front and rear axles. This unusual setup is rarely seen because of the complexity in ride tuning and kinematic response. But in McLaren's case, the goal may be packaging. By minimizing the upper suspension arm bulk, they create more space for airflow and energy recovery components. That being said, the leak also hints at adaptive damper systems, and under 2026 regulations, anything resembling active ride control is tightly regulated, even if passively actuated. One of the most debated elements in the leak diagrams is battery positioning. Rather than mounting the energy store flat beneath the monocoque, McLaren has apparently chosen a vertical placement stacked along the car's spine. This design has clear benefits in crash integrity and thermal protection, separating the battery from direct aerodynamic zones. But the compromise comes in weight distribution and balance. A high-mounted battery raises the center of gravity, and if not perfectly counteracted by ballast or structural tuning, could lead to instability under combined braking and cornering loads. Further intrigue comes from the dual-circuit cooling system revealed in the blueprints. It appears McLaren has split the thermal management into two completely independent loops, one for the internal combustion engine, the other for hybrid systems. This creates precision in temperature control but adds massive complexity in packaging, especially with smaller radiators mandated by 2026 rules. Any hint that these ducts rely on indirect airflow manipulation could open up regulatory concerns, especially if passive cooling is aided by bodywork shaping not explicitly allowed. The most controversial element might be the rear wing assembly. In the image, the mounting struts appear unusually flexible, with indications of a passive load adaptive mechanism. This has raised speculation that McLaren is testing a semi-active drag reduction system that changes geometry under speed without electronic input. While clever, this approach walks a razor-thin line with FIA rules on non-movable aerodynamic surfaces. If the wing is deemed to flex or deform under load in a way that changes airflow behavior, it could be ruled illegal, even if the materials technically pass static tests. Finally, the image shows unusually large access modules behind the cockpit, most likely related to telemetry, override, and hybrid safety systems. These are standard in modern F1, but McLaren's dual interface design hints at a more complex logic control layer. That raises two issues. First, whether these systems allow real-time override of torque distribution, which would violate Article 8 of the power unit regulations. Second, whether competitors can now infer McLaren's energy strategy from the physical placement and wiring layout. In either case, the leak has turned what should have been a sealed black box into a point of competitive exposure. Inside the McLaren Technology Center, the moment the leak hit public channels, the atmosphere changed instantly. Development screens froze. Access to design files was revoked. Protocols shifted from performance optimization to digital lockdown. Technical directors ordered a halt to all remote server syncing. Only a handful of senior engineers were allowed to access the car's 2026 folders. What had been a focused, progressive phase of concept refinement turned overnight into a crisis management operation. The timeline McLaren had planned so carefully, from wind tunnel to simulation to assembly, was now in jeopardy. The aerodynamics department was hit first and hardest. Their designs, months in the making, tailored to the limits of the new regulations, had been exposed before validation, before FIA sign-off, and before competitive deployment. But worse than the leak itself is what it implies, that McLaren had intended to operate on the very edge of legality. Floor flex zones, diffuser shapes, and wing geometries that were once safely theoretical now appear aggressive, maybe even confrontational. The fear now isn't that they did something illegal, it's that they may be asked to prove they didn't. Powertrain integration specialists are also under pressure. The vertical battery placement shown in the blueprint wasn't just an innovation, it was a calculated risk. Internally, it had sparked debate about cooling flow interference and energy surge isolation. But that conversation was supposed to happen in private. Now, the FIA could request simulation proof or bench test data long before McLaren was ready to publish results. And that means a major shift in workload. Resources that should be focused on optimization now must pivot to legal defense and regulatory transparency. Meanwhile, the Control Systems Division is racing to double-check logic paths on the telemetry modules that were revealed in the cockpit blueprint. The concern isn't about what the systems do, it's about what they might appear to do. In modern F1, perception matters almost as much as compliance. If a rival team sees even the potential for mid-race intervention or automated torque shifting, they'll flag it to the FIA. And once that spotlight is turned on, the burden of proof lies entirely with the team. Every wire, every failsafe, every piece of software must be audit-proof. Simultaneously, team leadership faces a far more delicate challenge: maintaining internal trust. A leak of this scale always leads to suspicion. Who accessed what? When was the data last exported? Was this an internal mistake or an external breach? While McLaren's technical operations run with military precision, even one compromised link in the security chain can destabilize the structure. Andrea Stella now finds himself not just managing a race team, but calming a shaken workforce. Because in Formula One, doubt is poison and no one performs at their peak under suspicion. Complicating matters further is the presence of Oscar Piastri's name on multiple leaked slides. It's a reminder that this is no longer just an engineering issue, it's now personal. Piastri's 2026 development program, tailored to his feedback style and mechanical preferences, is no longer private. That undermines driver trust and compromises long-term planning. How does a driver commit to a car philosophy when the rest of the grid has already seen the blueprints? It's a question McLaren now has to answer behind closed doors and quickly. Finally, while the factory scrambles, the rest of the paddock advances. McLaren's rivals are wasting no time. Every second spent on damage control is a second lost in the race to 2026. Wind tunnel schedules are being reshuffled. Simulation teams are isolating exposed designs and building countermeasures. What should have been McLaren's secret weapon, a bold, rule-pushing car, is now public knowledge. And in Formula One, if your enemy knows your weapon, they can build the shield before you even get to fire.